All right. And welcome, Mehdi and Simon. So now we have Cambridge Quantum Computing, and I see Simon is starting. So let me just quickly introduce our two speakers. So Simon McAdams started his academic career with a bachelor in biochemistry, and then moved on to tissue engineering for regenerative medicine in his master's, and finally graduated with a PhD in nanoscience from the University of Manchester. Today, he's the lead for the quantum chemistry product at Cambridge Quantum Computing. And I think Simon will talk about the quantum chemistry side of the work that you guys do. And Mehdi will talk more about the about the business side of a quantum computing software startup. Mehdi is an expert on high performance computing, and his academic background is in both physics and math. At the University of Sherbrooke, he graduated in 2003, and he studied quantum mechanics and numerical simulations. He then went into high performance computing and joined IBM, where he worked for 14 years, after which he followed his passion for disruptive technologies and joined Cambridge Quantum Computing in 2020, where he is the head of business development and offerings. Give it away. So questions again go into the Q&A box. I think you have until 17:45, right?
Yeah.
Okay. Welcome.
Well, thank you very much.
Thank you.
Thanks for the introduction, and nice to meet everybody. And yes, my name's Simon, and as in the introduction, I'm the quantum chemistry product lead here at CQC, and I'm going to give you sort of a quick introduction to Cambridge Quantum, talk about our quantum chemistry activities, and also some of our machine learning activities and what we're doing with our various corporate partners before I hand over to Mehdi, and then we'll have Q&A at the end. So without further ado, let's get started. So if you're not familiar with Cambridge Quantum, we were established back in 2014 as a spin-out from the University of Cambridge. So we're certainly one of the oldest quantum startups out there. And we started with just 2 people, but now we have over 150 people now in the company. So we're certainly one of the largest quantum computing startups out there as well. So we have about 150 people, and they're spread across the globe. So we have offices in the UK, in London, Cambridge, and Oxford. We have teams in the US and the East and West Coast, a team in Japan, and we just opened up an office in Germany as well. So we are purely a quantum software company, and we develop hardware agnostic enterprise quantum software. It says here that we are independent, and we certainly are, but you've probably seen maybe on your LinkedIn feed that CQC and Honeywell Quantum Systems announced last week a merger. So we will be combining with HQS to form a new entity. So we will become, by proxy, a hardware company as well. But right now, we are purely a software company, and we build software that leverages today's NIST devices for different applications. So this is our software stack. At the very center of our stack, we have our quantum software development platform called Ticket. And this allows us and our users to be both language agnostic and hardware agnostic as well. And I should mention the Honeywell merger won't affect our hardware agnosticism, so we will remain fully hardware agnostic even after the Honeywell merger. So I won't touch much on Ticket today because Mehdi and our quantum evangelist Mark Jackson will be speaking about Ticket on Friday. So Ticket, like I said, is at the center of our software stack. And then on top of Ticket, we have our various application programming frameworks for quantum chemistry, machine learning, and optimization, which I'll speak about today, but also natural language processing and cybersecurity, which are a little bit beyond the scope of this presentation. I'll just quickly say that for NLP, this is by far our most nascent sort of application programming framework, but one that gets a lot of people very interested. It's kind of the team's led by Professor Bob Cook, who was at the University of Oxford, but joined CQC earlier this year. And they've kind of already laid the foundations whereby a quantum computer could provide a quantum speed up to NLP tasks where there's a need to understand the grammar and the structure of sentences. And they recently, or a few months ago, implemented the first QNLP experiment on a real quantum computer. And then we have cybersecurity. This is, again, sort of kind of a separate division, but we can actually run a protocol on NIST devices to generate certified entropy that can be used to seed quantum safe keys for security applications. Okay, so then the next layer up, we have our collaborator use case. So in addition to developing software, we also work with various collaborators across various industries where we work toward quantum advantage for their particular use cases. And I'll discuss sort of each of these in turn, but it varies from, chemistry applications with Nippon Steel to, machine learning applications with Aker BP and DHL. But more details on that later. Okay, so first we will start with our quantum chemistry platform called Human, which, as you've probably guessed, stands for Eigensolver of Unitaries for Molecular Energies. And it is a hardware agnostic, Python-based framework that allows users, whether they are computational chemists or quantum algorithm developers, to really get sort of best-in-class results using NIST devices for their quantum chemistry simulations. So essentially, users can mix and match the latest quantum chemistry algorithms with different quantum subroutines and error mitigation techniques to run their quantum chemistry simulations on NIST devices and simulators. Human is, of course, integrated with tickets. So Human takes advantage of tickets, circuits optimization and circuit qubit writing protocols, and really reduces the qubit requirements that are needed for quantum chemistry simulations on quantum computers. And as I kind of alluded to earlier, Human has been built with our Fortune 500 partners and collaborators across different sectors, from pharma to automotive industries as well. So something that's really fundamental to Human are these sort of fragmentation techniques that you can see in the bottom right-hand corner here. So these fragmentation techniques allow us to take relatively large systems and break them down into smaller chunks, if you like, and allow us to run those chunks on the quantum devices and then stitch the results back together. And it really means that we can start to tackle much larger systems than otherwise would be possible using sort of traditional quantum chemistry techniques. But more on that later. So this slide gives you an idea of sort of the workflow of Human. So starting on the left-hand side, we take some input, which can be a molecular material system up to about 30 atoms size. These fragmentation protocols that I mentioned on the last slide, they really allow us to tackle these large systems. If it wasn't for these fragmentation protocols, we'd only be able to simulate maybe 3 to 5 atoms on a NIST device. So once you have your system of interest, we then need to define that problem, and we define the problem using sort of a suite of classical chemistry drivers, and you can select from sort of molecular chemistry drivers or these periodic boundary condition drivers that allow us to tackle sort of solid state crystalline systems. And then we have various embedding protocols that I had mentioned previously. So once you've sort of specified your problem, or we call it, you've humanized your problem, you can then select from different algorithms, which you can see here. And so if you're familiar with quantum chemistry on quantum computers, you'll recognize these algorithms. So we can actually implement new algorithms that appear in literature very easily within Human, and we even have our own sort of proprietary implementations as well. So then these algorithms are kind of broken down into sort of smaller subroutine protocols, which you find in this protocols and error mitigation module, where you can sort of mix and match your algorithms with different quantum subroutines and error mitigation techniques. Once you've done that, you can then send your algorithm to your backend of choice via Ticket. So whether it's a hardware or simulator, you can then use Ticket to retrieve your results, carry out some post-processing steps to get your results of interest. And you can see some of those examples here on the right-hand side. So we like to make it sort of as easy and as quick as possible to really run your chemistry simulations on these devices. So as I mentioned, Human has kind of been developed in partnership with various corporates, and I just want to say a few words of what we've done with them. So we're actually currently working with Roche on looking at sort of binding affinities of small molecule drugs to various target proteins. So we can't really mention more than what's in the press release, other than say we'll hopefully be publishing this work in a few months time. We have published some work with Nippon Steel. You can find the paper in the bottom left-hand corner here. So the work that we did with Nippon initially is that we took the standard molecular VQE algorithm, which you traditionally use to find sort of ground states and in some cases excited states of systems. And we adapted that molecular VQE algorithm to solid state systems and allowed us to sort of benchmark this novel algorithm on different hydrogen and helium lattices. And we should have a paper coming out in the next couple of weeks where we take this molecular VQE algorithm that we've applied to solid state systems and then apply it to Nippon Steel's use case of interest, which in this instance is looking at iron crystals and benchmarking two different types of iron crystals. And then last but not least, we've also been working with Total for the last, well, it must be in the last 18 months now. And again, it's solid state chemistry, but we're looking at this time these metal organic frameworks, which you can use for CO2 absorption and storage. Although you can start to swap out for different gases if you're interested in H2 storage as well. So that gives you a flavor of some of the problems that we're working on and that you can sort of start to tackle within the Human framework. Okay, so moving on to our other application programming frameworks for quantum machine learning and optimization. And we normally group these two together because it's the same teams that work on these. They're based in London. So with quantum chemistry, I'm sure you're aware there's sort of a clear sort of exponential speedup that is attainable. With machine learning and optimization, arguably the speedup is less clear. You know, is it exponential? Is it quadratic? Do you require QRAM or quantum RAM? So an efficient way to embed your data into quantum states. So at CQC, we work with these things called parameterized quantum circuits, which are kind of like neural networks, but for quantum computers. And we have this review paper here that you can find with more information. But these methods are kind of general enough that you can apply them to different techniques you'll be familiar with. So we're interested in supervised and unsupervised learning. Generative modeling is a big part of what we do. Also sampling problems like Monte Carlo as well. These are just some of the things that we focus on, and also reinforcement learning as well. So some of the work that we've been doing with some corporates includes some work with Aker BP. So this is a supervised learning problem where they supplied us with this synthetic data set. You can see here on the left-hand side. So there's about 10,000 data points, 2 different features, 3 different classes. So you can imagine a pipeline with oil and gas flowing through it, and the different relative velocities of the 2 phases gives you smooth flow, wavy flow, solid G flow, shown here in the green and the yellow and the purple. So we trained our model using these parameterized quantum circuits on 250 randomly selected data points, which you can see in the dark crosses here. And we found that we could get a test accuracy of about 87%, which was comparable to sort of standard classical SVM type methods, albeit this was in a small sort of toy data set. But nevertheless, we could match the performance of sort of classical techniques, and we only needed to use 3 qubits. So the next step is to see whether we could get some quantum advantage. So can we improve classification accuracies using quantum computers? So the idea is that we can take data, we can map it to high dimensional space, and this is something that is non-trivial to do with a classical device, and hence there could be some quantum advantage because we could start to tease out our data points and draw correlations that otherwise wouldn't be evident using classical devices. It's worth saying that there is a theoretical exponential speedup when it comes to data classification, but this requires QRAM or quantum RAM. We also recently announced work we're doing with Crown Bio, GSR, and this is looking at predictive biomarker analysis. So can we look at patient's genome and predict whether they would respond to a particular drug or not. So today, if you want to do sort of comparative genomic analysis, looking at 2 genes is tough enough. I think looking at 2 genes, I think there's 10 to the 8 different combinations. But when you want to compare 3 or more genes, suddenly there's 10 to, I don't know, the 20 different combinations. So the problem quickly explodes, and hence why it could be a good problem to look at using quantum devices. And then last but not least, we're also looking at, or we also did work with DHL and Honeywell. So DHL have this knapsack problem. So trying to optimally pack and deliver a container with boxes and trying to minimize the amount of air that is shipped in these containers. So they wanted to kind of tackle that problem in a quantum device. And Honeywell have this H1 device, which is the most powerful device that's been sort of measured to date, this 10-qubit device. And they wanted to showcase that device. So CQC kind of sat in the middle and sort of facilitated that workflow to implement this knapsack problem on a quantum computer. And you can actually go to the DHL website. I think it's called the Future of Logistics Masterclass to actually see the work that we did. But to summarize that, we found a way to sort of embed the problem. So you can imagine spin up of your qubit means include the box in your container, and spin down of the qubit means discard the box. And the sort of the lowest energy state of these qubits gives you the maximum weight that you can pack into a delivery vehicle. And again, this is a toy problem, so we added different constraints. So you can imagine trying to stack a 1D stack of boxes inside a container. But nevertheless, we showed it could be done. And I guess the next step is to see whether there would be a quantum advantage using a quantum computer to tackle this problem. And last but not least, some of the work that we just announced with DLR. So this is looking at nonlinear partial differential equations and whether we can run these on this devices to tackle lithium-ion battery simulations. So DLR currently use nonlinear PDEs to simulate lithium-ion batteries. And so they want to see whether they could use a quantum computer to do the same. So 1D simulations are kind of doable right now classically, but 3D simulations are kind of pushing the limits of what you can do classically. So we anticipate that quantum computing could potentially be useful for 3D PD simulations in the future, but that's what this project aims to find out. And you can find a paper in the bottom left-hand corner here. This is some work that one of our scientists did, Michael Lubash, looking at nonlinear PDEs on NIST devices, and this is what this work stems from. Okay, so before I hand over to Mehdi, I wanted to say that if you want to learn more about Ticket or Human, please contact us here. If you want to be considered as a human beta tester, which we're currently doing, please go to our GitHub page and you can find the human support email and drop us an email. Also, read our publications, follow us on LinkedIn as well, and visit our YouTube channel as well. So thank you, and I'm going to stop sharing and hand over to Mehdi, and yeah, we'll see each other again when we do the Q&A. Thank you.
Thank you, Simon.
Thank you very much, Simon. Let me share my screen. Here we go. Can you all see my screen? Perfect. I mean, thank you very much again for the opportunity. It's a real pleasure to talk about productization and commercialization of research. That's what it is at the end of the day. So let's start. So some context first, and that's the Cambridge quantum use case. So we, as Simon presented it, we have all those frameworks like programming framework, or we can call them research frameworks. Some of them are already consumable by end customers. That's the case for Human. And the underlying, I always call it my concrete slab, that's Ticket. So Human is very special in the sense that we're going through beta testing right now, and it really looks like a product. When quantum frameworks for quantum machine learning and quantum optimization are still frameworks that can be used and leveraged internally in order to deliver a research output to end customers, but not ready yet for final customer consumption. And QNLP is emerging, so we'll see what it looks like in probably 1 year or 2. Now, that's the full stack, as Simon mentioned it. So it completely makes sense to consider all the moving pieces in our framework, and all of them are interconnected. So Ticket is extremely interesting because as it is connected to every single programming framework, every single time you improve Ticket, then all those frameworks will benefit from this improvement. And then the collaborative use cases are absolutely critical because that's how you get basically feedback from customers and the market. And again, we are completely backend agnostic. So that also lets our customers to find out how one specific algorithm that was tuned for their specific use case would behave on different hardware platforms, which is quite critical. Now, let's say I am a PhD student or a postdoc. I have a wonderful idea. What's next? So next is really, how do you make this idea fly and be accepted by the market? So you need to go through like multiple steps. And so we've identified that CQC, first it's productization and commercialization. So we are lucky because with Ticket, we have the foundation. And again, that's why I call it my concrete slab. So we did build the foundational layer that is common to all frameworks. Again, hardware agnostic, and it also connects existing frameworks with added value, like for example, circuit optimization and the combination of circuit optimization and noise mitigation, or the ability to actually not ask anyone to learn a new framework from scratch, but end users can still use whatever they know. Like the best example would be Qiskit in this case, and then insert Ticket on top of Qiskit in order to benefit from this added value. So foundation, it's done. What would be the next step? So again, all those frameworks, and I call them frameworks because most of them are not product yet. And the exercise is really to go from a framework that you can consume internally in order to give value to your customers, and through co-development. So why co-development? So usually when you start building a product, like any product that you can see on the market today, you need to go through some, again, exercise trying to find out, okay, so what will add value for one specific customer, and how do you insert this into your roadmap? And you never know if it will be a full success because, I mean, market studies are not 100% accurate, never. So co-development is actually really cool because in this case, you work with one very specific customer and you are 100% sure that you are on target. So that will allow you to develop specific features for your future products. And also the cherry on top of the cake that you get as a startup is you can also be a bit picky in the sense that if you get customers across multiple verticals, and then you get a good idea of the sizing of those verticals, it becomes obvious that you really want to put all your energy working with a customer that is attached to a vertical that is, I don't know, size 3 billion versus a size of, let's say, 500 millions. Then what it allows you to do as well is to go through immediate monetization. And usually when you develop your product, I mean, you're not making money. That's a given. You will be making money once the feature is added to the final product and then you sell this product. In this case, again, the co-development phase, we're talking about research contracts. especially in the quantum space. So you can actually make money right at the beginning, which is always good. And also you create IP, which is even better. The other very good thing that you get through co-development is what I call stickiness. At the end of the day, if you are a customer and invest in working with a startup for developing what will be the product that you need, the chances that you drop the product once it's ready are like super low. So that's what I call stickiness. The next step, and this is not an easy step, is how to transition from frameworks to products. So at the end of the day, you really want to have your products to be consumable by end customers. And what you have at the beginning with co-development is a framework that may be used by very specific customers, but it's not a product yet. And that's this transition that is absolutely essential, because then it will give you sales enablement, but also partnerships enablement, which will be critical for the scaling part. The next step, of course, is commercialization of those products. And it's all about being able to execute on a streamlined sales process. Now, scaling, I mean, everybody's quite far from this one, but the idea is really that through prioritization and partnerships, then now you have a product not only that is consumable by end customer, but that is consumable by partners. And you may be like super good at research, but not really good at, let's say, UX and GUI. So you can partner with specific companies who are extremely good at delivering end products, who can leverage your, at the end of the day, algorithms. And the cloud consumption, especially, is really in the scaling part. So I did put at the bottom like two zones, enablement and engagement, and that's really what it is. You enable your startup during the first three steps: foundation, co-development, and productization, and then you can fully engage with customers during the last two phases, commercialization and scaling. So the other thing that you can get from this diagram is also that during the co-development phase, for example, at the end of the day, you still need to sell something, and that's your research engagement. So you need people who are experts in specific verticals to do that, because you need to establish the trust with the final customer in order to first pique their interest and then demonstrate that going through this co-development phase will give them something that is valuable. And at the end of the day, what is valuable for our customers is through these engagements, they are quantum enabled, like they will learn, because all the time, almost the only research teams that they have are classical research teams. So that's the first thing. And then they will get a very good and accurate idea when you combine a research engagement with the fact that we are hardware agnostic, so we can actually benchmark multiple technologies. And if you put these together with the official roadmaps from the hardware vendors, then you end up with a pretty good idea when you can reach quantum advantage, which is quite essential for our customers, because not only they know, or at least they have a good idea when they will be able to extract commercial value from quantum computing, but that also gives them a very good idea when the competition will also be able to leverage quantum computing techniques. So in the pre-engagement zone, again, it's all about early monetization, which is quite essential for a startup, because you want to be a bit independent of funding, and that's one way to do it. Now, how does that translate in terms of organization? So that's basically the existing functional org chart. That's what everybody starts with. So you have one function that is just lead generation. I mean, you need to know who are the main players for specific verticals, who do you need to talk to and engage with? So that's the lead generation piece. And then opportunity owners are people who are going to negotiate and sell these research engagements. So that's really the co-development phase. So once you have frameworks very well identified, then the key is first start thinking about the prioritization. And that's why this opportunity owner function is now attached to a framework ownership. So typically a framework owner will be the product owner once prioritization is achieved. He or she is also typically an expert in his or her field. Like, I mean, Simon is the best example, because once you engage with customers, you need to first speak the same language and also have a pretty good idea of what are the pain points they are facing. Then, in order to be more efficient and more accurate, you absolutely need to have a team up between lead generation and market intelligence. The example I always give is, I mean, take any of our customer, Total, for example. So Total is a massive organization. And if you know exactly or precisely what are their research budget, and all of this for the main companies are publicly available. You know which team is doing what inside Total or Roche or whoever is your customer. Then you can also identify multiple opportunities, and especially when you have multiple frameworks. So that's basically, it's building some kind of topographical map. Then the evangelist is really the function of pushing the branding and the technology awareness throughout the market and the main players. Then, of course, lead qualification, framework owner, and then I added in this case a new function called relationship manager. And that's really the person or the function that will help in not only making sure the delivery of these research engagements are successful, but also establish a very strong partnership with our customers and any customers that a startup may have. Because at the end of the day, yes, you want to deliver some kind of research output, added value, but you also really want to be seen as a trusted advisor. And that's the function of the relationship manager. So that will be essential through the co-development and prioritization. Now, how does that scale? So that's the final diagram. So we still have this lead generation and market intelligence, the evangelist, but now we have framework owners and opportunity owners per framework. So what does it mean? Actually, it means that if you want to get more deals, then this becomes a team with still the same function. If you want to add a brand new framework like QNLP, for example, then you just scale it up, scale the organization horizontally in this case, and add a brand new framework here. Once you go through the full prioritization, which is the case for a human, then it's time to split the organization. So the framework owner will become a true offering manager or product manager, and you're able to split the organization and have the opportunity ownership piece of this function to be pushed into the sales organization. And then it's really like a split. Sales on one side and then product on another side, so that it starts looking like a standard function organization. And I mean, all the numbers are, I mean, typical, like conversion rate of 30%, upsell 20% of the contract yearly. So that's what you can find in the literature. So more deals or more leads, let's put it this way, you add people there, then you will have to be able to handle more deals. So you add opportunity owners there. And that's very nice because you need only one framework owner, but you can add as many opportunity owners as you want to. And those all opportunity owners will then move to the sales organization. And it's the same for all frameworks. And what's nice as well is they are independent. So human, for example, can be first. That's absolutely not a problem. And then followed by the QML and optimization finance pieces. And again, you get more customers at the end of the day, so you can beef up the relationship manager team. So that's fully scalable, both sides, vertically and horizontally. Now, as a startup or as a potential founder with a wonderful idea, then there's lots of questions that you will have to find answers to. First, IP. So what do you want to do with IP? How do you want to make sure that you keep your IP so you can build on top of it? And then you will get questions from your potential customers, like because they also want access to this IP. So that's one of the big questions. Then consulting. Do you want to do consulting, like to bootstrap the company, or do you want, like day one, to clearly state that no, I'm not going to do consulting. I'm going to go on down the product path. So this will have an impact on funding, for example. Then what about open source? So open source versus closed source versus hybrid. So that's also a very good question. We saw like very good example of open source projects. I mean, the first that comes in mind is Qiskit, but there's also Penny Lane from Xanadu, and that's a question that you will have to answer. Then commercial engagements versus public funding. That's also a very interesting question because you can actually apply and then get public funding. That's one thing. Then you're tied to specific projects. But if this public funding at some point, I mean, it's limited in time. When if you do commercial engagements like this co-development step in the life of the startup, then as long as you are relevant and add value from a customer point of view, you will get some revenue stream, which is always good. It's permanent and it's really tied to how good or how relevant you are for these specific customers. And again, you can spread across multiple verticals just to diversify your, let's say, portfolio. Free POCs. So that's one thing that comes up every single time I talk to startups. The big question is, okay, I'm a super young startup. Should I do free POCs in order to get some publicity because I work with like one of the big player in one specific vertical? I would say be extremely careful about those ones, because what happens is every single time you give away something for free, it will lose priority. So as a big company, I don't know, let's say a bank or a big pharma company, they are always engaging with startups and doing POCs. So let's check one very specific use case. You're a big company and you have two POCs, one that you paid for, and all of them have a specific timeline. One that you paid for, and of course you're involved, you have to do something. And another one that you got for free, that is maybe super interesting, but it's free. So when you're getting closer and closer to the deadline, as a big company, you paid for something and you have to deliver something again. You're not going to drop this one. You're going to, if you're late, you're going to put resources on the paid POC versus the free POC. And what happens lots of the time is, you have a wonderful POC that you offer to one big company, hoping for some basically marketing outcome, but it's dragging and dragging and dragging. And that's really the danger with free POCs. The next question is when to collaborate with academia, or maybe not. So it comes down to And that's a very funny situation because almost every single university has different IP policies. And it's really tied to IP policies. You don't want to collaborate with academia if academia takes basically all your IP. So that's not a good deal. If it's all about sharing the IP or doing something together, definitively yes. And especially if you can leverage some funding, which is the case in Canada, when you have one customer, one startup, and one academic entity, then you can apply for funding from the government and basically get, let's say, a PhD student or a postdoc half of the price because it's half funded by the government. And it's lots of countries have similar programs. Then incubators. So should I go and be part of some kind of incubator stream? And what I have in mind right now is CDL, Creative Destruction Lab in Toronto and their quantum stream, which is the only quantum stream available today. That's a good question. That will give you lots of things, lots of inputs, basically coaching from from experts in their fields, from business to science, and all those questions. I would say, as a startup, you're better to have answers to those questions before you do any move. And it's all about executing on a plan that is not studied, but you absolutely need to be agile. Another thing that I keep saying is there's no better way to find out if your product or your idea of a product is valid and will add value to specific customers. Nothing better than trying to sell it. If you try to sell something 10 times and you're just not successful, it means only one thing. Even if it's a wonderful idea, the market is not ready for it. And if the market is not ready for it, that's not going to be a success. So it's a wonderful way to get feedback from the market and also make sure that you stick to one specific or multiple verticals, keep adding value, and then it's this actually wonderful feedback loop, and that's the only way to get products that will stick from my point of view. So that's it for my presentation. If you want to reach out, so I'm always available on LinkedIn, or you can ping me at CQC there. So that's my email address. And again, thank you very much for the opportunity. And if you have any questions, let's go.
Yeah, thank you, Mehdi, and thank you, Simon, again, for the great talk. Just before I forget, I was wondering if you could share the slides with us so we can distribute them afterwards.
Yes.
Thank you very much.
Yes, that's absolutely not a problem.
And then we have a question in the Q&A. If, Simon, you could elaborate a bit more on the fragmentation technique. I think DFET was the name. In the human framework, like what happens at the boundary of the fragments, and maybe how big are the molecules that you can tackle?
Sure. So I'll preface this by saying I'm an experimental chemist rather than a computational chemist. But from what I understand with DMET, for example, so you take your molecule, you split it down into sort of 5-qubit fragments, say, and then you take a fragment and you're going to perform VQE on that fragment. And in terms of the boundaries, the other fragments in your molecule make up a kind of effective bath that your fragment sits in. So say you had a sort of a sheet of graphene, so you have 4 atoms in a cell, so that's 8 qubits. So you can solve each fragment 8 qubits, 10 times. So you only need 8 qubits to simulate that graphene sheet. But if you wanted to simulate using without using DMET, you need about 80 qubits, which of course is completely infeasible on this devices, whereas you can certainly do 8 qubits today. So that's DMET, and then the other techniques include QMMM, which are analogous to the QMM methods that you use classically, but in the quantum computing version, the QM portion is performed using the quantum computer with a high level of theory, whether it's FCI methods, and then the MM part would be performed with some classical approximation using, I don't know, force fields or empirical methods.
Excellent, thank you. I have also a few more questions. Maybe if I can ask you, maybe you mentioned a few times this co-development and building your own products kind of trade-off. How did or does CQC balance that you, basically, if you co-develop something with someone, like it's easy because you're on point, but also you give them IP and you don't end up with maybe your own product.
Yeah, so what you really want to do as a startup is you want to keep the IP, and what you can do is, and it's the negotiation phase with the customer when you sell this research engagement, you can say, for example, you know what, I'm going to keep the IP, but whatever the outcome of the research engagement is, we will license it back to you. So it's a win-win situation because as a startup, you own the IP, so you can build on top of it. But as a customer, even if you don't own the IP, you can actually also build on top of the research output. So on both sides, you can. There's an evolution path that is possible. And some customers. So I'm not saying it's easy. It's actually a very difficult negotiation exercise because some customers can say, for example, you know what, we really want to make sure that our competition is not going to get access to this. So we want you not to, for example, work with direct competitors for a specific period of time. So that can happen. That's also quite usual.
Okay. And then maybe also on the business side, like what do you tell your customers about the perspective on hardware? Because I mean, you're building software for devices that don't really exist yet.
So we have partnerships with hardware vendors, like the big ones, to be honest. But we also have partnerships with emerging hardware startups. And that's exactly where you have to articulate something, because most of them are not ready yet. I mean, if you go through what exists today, you have companies like, so you have AQT, you have Honeywell, you have IBM, but you also have like IQM, and you have Archer Materials, for example, in Australia, that is like right at the beginning. But you also have Pascal, for example, in France, or Alice and Bob. Like you have many possibilities. But what you can always tell your customers is, you know what? Whenever those small players are going to be ready for running these calculations, we will be ready as well, and you will be ready as well because of this underlying, in our case, it's ticket. But we won't have to recreate the algorithm, use another framework to encode it, and so on and so forth. So in terms of agility and actually being able to very quickly react to new hardware platforms, that will benefit the end customer and yourself as well as a startup.
Okay, cool. And with respect to the time, maybe one more question from the Q&A. If you could quickly comment on such non-competition clauses you just mentioned, and in which cases would they be acceptable?
So to be honest, it really depends, and that's also why as a startup you need to be like extremely agile, because if, let's say, for example, you sign an agreement with one specific customer, this customer asks you not to work with one of their competitors on this very specific subject, then it's the question is it acceptable or not? And then depending on the duration of this, basically the time, you cannot execute on something equivalent with another customer. So what's, for example, the hardware roadmap? Because if you're tied to only one customer and you cannot come up with a product basically But at the same time, it is expected that given the state of the hardware in, let's say, 2 years, someone will get quantum advantage in this field. That's not going to be good for you, because your own competitors may not have these all those strings attached and may be able to move quickly on this vertical. So it's moving extremely fast. Let's put it this way, and it's not easy, because we're talking about years. It's not 6 months. It's usually years. And it's all about assessing the market as a whole, hardware and software. And that's also where the market intelligence comes into play. Like you just cannot run full speed blind. You have to see what are the obstacles, basically.